Okay, pre-cal students, in this video, we will be studying many things that we can do with matrices. Please take really good notes, okay? Here we go. Your heading for today is called Matrix Operations. Matrix Operations. Please copy that down. The lesson number is 14.5, and be sure and include today's date, alright? Let me fix that real quick. Be sure and include today's date. Matrix operations. Alright, let's continue on. Let's start first with describing equal matrices. It is a really simple concept, but let's still make sure that we understand it. So, below is an example of equal matrices. I would encourage you to write this down. That is up to you. Do you not see how amazingly easy this is? First of all, both matrices have to have the same order. 2 by 2, 2 by 2. Next, each entry has to equal its corresponding entry. So there's a 2 here, there must be a 2 here. There's a -1 here, there must be a -1 here. We have the square root of 4 here, which is the same thing as 2. I have 1/2 here, which is the same thing as 0.5. Now, understand, you do not have to have a square matrix in order for matrices to be equal. I just chose to use square matrices just for the fun of it, okay? Now, should not have done that. Now, listen to me carefully, guys. Do you understand what equal matrices are? Two matrices are considered to be equal if they have the same order, and by order I mean dimensions, and each entry is exactly equal to its corresponding entry. Okay? So that's what equal matrices are. Please understand that. Okay? If I had an X right here and a Y right here, and I stated that these two matrices were equal, then you would know right away X is equal to what? 2. So there you just solve for X. And Y equals what? 0.5. So you would know Y equals 0.5. Okay? Alright, let's continue on. Now let's move on to adding and subtracting matrices. Again, like the last concept, this is very easy to do. And if you remember this from Algebra 2, then you remember how easy it is. To state it simply, when adding or subtracting matrices, they must have identical orders, and you add or subtract each entry with its corresponding entry. Now, some of you might want to write this down. Some of you might not. I'm going to wait just a second in case you're writing that down. If you are, that's fine. If you're not, that's fine. When adding, and probably all of you remember this from Algebra 1 and Algebra 2 both, when adding or subtracting matrices, they must have identical orders, and you add or subtract each entry with its corresponding entry. Now, let me demonstrate this to you, okay? I want you to take a second, and I'm going to pause for a second and let you copy these down. I want you to copy these two matrices in your notes, please. Matrix A and matrix B. Make sure that you copy them correctly. Okay, I'm going to continue on, and if you're not done copying these, you can continue to do so. Now, I'm going to go ahead and look at problem number 1 here. We're going to take A plus B. So here's matrix A. Here's matrix B. I'm going to add these two matrices together, okay? A plus B. So here we go, it's very simple. 2 plus 2. Well, first of all, let's do a quick check. Do we have the same order? Yes, we do. We have a 3 by 3 and a 3 by 3, so we're good. 2 plus 2 is 4. 2 plus 0 is 2. And 4 plus 0 is 4. Alright, negative 3 plus 1 is negative 2. 0 plus negative 4 is negative 4. Negative 1 plus 3 is 2. 2 plus negative 1 is 1. 1 plus 3 is 4. And 2 plus 2 is 4. So students, there we go. Adding matrices is really, really simple. Okay, so there we've added two matrices together. Now let's continue on and let's go ahead and subtract a couple matrices here, okay? Now, students, this is going to be your choice, okay? You're big high school seniors, so whatever you choose to do is fine. We have A minus B, okay? A minus B. Now, if you want to do it this way, that's fine. A lot of students like to make this a plus sign and then go through and change all of the signs over here. So if it's positive, we make it negative. If it's negative, we make it positive. Students like to do that because to them, it's easier to add than it is to subtract. I really don't care. That's totally up to you. Do what is easiest for you, okay? I'm going to leave a subtraction right now. So here we go. 2 minus 2 is 0. 2 minus 0 is 2. 4 minus 0 is 4. Alright. Negative 3 minus 1 is negative 4. 0 minus a negative 4 is 0 plus 4, and that's 4. Negative 1 minus 3 is negative 4. 2 minus a negative 1 is 2 plus 1, that's 3. 1 minus 3, negative 2. And 2 minus 2 is 0. So there we go. There's two matrices being subtracted. Okay? If I'm going too fast, just pause the video. This is really pretty simple stuff, okay? Now lastly, we're going to take 3a minus 2b. So now we have a 3 here minus 2b. So 3a minus 2b. Now here's what you do, students. First of all, you take this 3 and multiply it through. So now I have 6, negative 9, 6, 6, 0, 3, 12, negative 3, 6. Now, you have a choice, students. You can multiply a negative 2 through and change all the signs and put a plus sign here, and that's totally acceptable. Or you can put a minus sign here and subtract a positive 2 through. That's what I'm going to do. So I'm going to bring the minus sign down and multiply a positive 2 through. But there's nothing wrong with putting a positive sign here and multiplying a negative 2 through the entire matrix. Either way, you will get the correct answer, okay? Alright, I'm bringing the negative sign down and multiplying a 2 through. So 4, 2, negative 2, 0, negative 8, 6, 0, 6, 4. So none of the signs changed. They all stayed the same. And now here we go. Now I'm going to subtract these two matrices. 6 minus 4 is 2. 6 minus 0 is 6. 12 minus 0 is 12. You know what, students? With all this math I'm doing now, and with all the math I'm going to do before this video's over, I am bound to make at least 1, 2, or 3 little mistakes. So if I do that, just call it out to each other's attention. Make sure your notes are correct and keep going on, okay? I have to. Sooner or later make a mistake somewhere, and I probably won't catch it. Okay, negative 9 minus 2, that's a negative 11. 0 minus a negative 8, that's 0 plus 8. Negative 3 minus 6 is negative 9. 6 minus a negative 2, that's 6 plus 2, 8. 3 minus 6, that's negative 3. 6 minus 4 is 2. So hopefully, unless I made a mistake somewhere, there's your answer. Okay, so as you can tell, students, to be honest with you, freshmen in high school or middle school students could do this. It's really, really simple, and I think you'll have no problem with this, okay? Let's continue on. Now, let's take a look at let's take what we were just practicing and apply it to something called matrix equations. It sounds difficult, but it's actually also pretty simple, okay? So please copy this problem down. Please copy this down. Here's your matrix equation right here. So copy that down, and we're going to solve for x. In order to do that, though, we have to know what a and b are. So here's a. Please copy that in your notes. And here's b. Please copy that in your notes. Okay? There's a and b. Now, we're going to solve for x. Now, a lot of students like to do this, and I want to encourage you to not do this. They go ahead and put a matrix here and a matrix here. Then they got to move the matrix over and change the sign, and then divide by 3. Here's what I say. I'm going to get x by itself right now, and then put these in last. Let me show you what I mean. I go like this. 3x equals b minus a. Bring the a over and make it a negative a. Now divide by 3. So I have x equals b minus a. So you're going to subtract the two matrices and then divide by what? 3. Isn't that easy? Man, we can do this simply now. So here we go. B minus A. So, be really careful here. B minus A. And then we'll divide it by 3, okay? Or you could say multiply it by 1/3. Same thing. Divide it by 3 or multiply it by 1/3. Here we go. It's b minus a. So negative 3 minus 1. 4 minus a negative 2. That's plus 2. So 6. 2 minus 0. 1 minus 3. So there's b minus a. B minus a is this matrix right here. And now we're going to divide it by 3. So we're going to take each number and we're going to divide it by 3, or you can take each number and multiply it by 1/3. Either way, you'll get the same answer. So here's what x equals. X equals negative 4/3. 4 divided by 3. 6 divided by 3 is 2. 2 divided by 3 is 2/3. And negative 2 divided by 3 is negative 2/3. There we go, students. That's it. We just solved for x that quickly. Okay? So pretty simple. Not too difficult at all. Again, I hope you'll take my suggestion on taking the equation first and simplifying it down to where x is all by itself. And then go ahead and solve for x, okay? Alright, let's go ahead and continue on. Now, if you remember anything that you dreaded from Algebra 2 when you were working with matrices, it was probably matrix multiplication, and to be honest, rightfully so. Matrix multiplication is difficult to do. Now we're going to be multiplying matrices longhand. That means without a calculator and also with a calculator. So, with great excitement, here we go. Let's do this, okay? I'm not going to give you steps, but instead examples and explanations as to what I'm doing. So please take some really good notes. We are going to look at 3 problems, alright, in which we multiply matrices together. Please take some really good notes. Please pause the video when you need to, and please rewind when you need to, and listen to it again. Okay, here's the first problem. I'll pause a second while you copy this down. you listening, students? If this number here does not, I call these two numbers here the inside numbers because they're on the inside here. If these two numbers do not match, then you cannot do the multiplication. If this would have been a 2 right here, then you stop and you put no solution. You cannot multiply matrices unless the inside numbers match. Got it? So the first thing you do is you run a test, because I could see me very likely giving you one on a test or a quiz. That cannot be done. Okay? Moving on. Now, do you know what these outside numbers do for you right here? This 2 and this 3. They give you the dimensions of your answer. So now you know your answer is going to be a what? 2 by 3. So you know you're going to have 2 rows and 3 columns. So I put blanks in mine. That's how I do it. I know there's going to be a number here, 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 a number here, here, and here. That's a 2 by 3. I have 2 rows, 3 columns. Okay? So there we go. So let's go over this again. Always run a test first. If these two, write down the order of both matrices. And be careful and make sure you don't make a mistake there. If the inside numbers match, you're good to go. If they don't match, then stop and put no solution. Next, take the outside numbers, and those are your dimensions for your answer. Okay? So now that we've done all that, please take some really good notes. Here we go. You always take row times columns. Please don't forget that. You always take row times columns. So we start with our first row, and we're going to multiply it times this column here. Now here we go. Watch carefully, okay? 1 times negative 2 is negative 2. 0 times 1 is 0. 3 times negative 1 is negative 3. And then you add all of those numbers up. So I get a negative 5. There we go. Row times column, over and over and over. So I just took this row here times this column here. Now I take this row times the next column right there. So here we go. 1 times 4 is 4. 0 times 0 is 0. 3 times 1 is 3. Add those together, you get a 7. And you do go across. You always go across. As you're filling in these blanks, you will always go left to right, left to right. Okay? Alright, well, we're not quite done. We have one more column to do. We took this row times this column. We took this row times this column. So now I've got to take this row times this column here. Okay? So with that in mind, here we go. We have 1 times 2. That's going to give us a 2. We have 0 times 0. That's going to give us a 0. Then we have 3 times negative 1. That's going to give us a negative 3. We're going to add these 3 numbers together and we'll get a negative 1. Okay? So there we go. We are now done with this row right here. We know that we're done because we multiplied it by every single row over here in the other matrix. Okay? So I'm going to go ahead and put like a check mark here for this row. I'm done with that row. Now come down to your next row. We're going to do the same thing over again. Row times column. So let's see what happens. Here we go. 2 times negative 2 is a negative 4. Negative 1 times 1 is negative 1. And negative 2 times negative 1 is a positive 2. Combine those together and you will get a negative 3. Okay? Now, we've got to take the row times the next column. So this row here times this column right here. So here we go. 2 times 4 is going to give you an 8. Negative 1 times 0 is going to give you a 0. And then negative 2 times 1 will give you a negative 2. 6 over here. Alright? And then lastly, we take this row here times this column here. Okay? So here we go. 2 times 2 would be 4. Negative 1 times 0 is 0. And negative 2 times negative 1 is a positive 2. Add those together and you will get a 6. Okay? So there we go. We took two matrices, we multiplied them together. We're going to look at two more problems like this, then we'll move on to something else, okay? And students, here we go. Okay, copy this in your notes. I'll wait a second while you do this, okay? Copy this in your notes. You're probably thinking, oh, there's no way we can multiply these two matrices. They're too different. Well, maybe you're right, maybe you're not. We're going to run a test in a second, and we'll see, okay? Go ahead and copy down this problem. We're going to multiply these two matrices together. Alright, students, here we go. First of all, let's run a test. This is a 3 by 3. This has 3 rows, 1, 2, 3, and 1 column. This is a 3 by 1. So our inside numbers do match. So we are going to be able to multiply this. Our outside numbers here tell me the dimensions of my answer. My answer is going to be a 3 by 1. So it's going to have 3 rows and 1 column. So 1, 2, 3. I'll have 3 numbers going across and 1 column going up and down. So there's my 3 by 1. Alright. And let's go and get started. Here we go. Row times column. Okay? Row times column. So we have 6 times 1 is 6. 2 times 2 is 4. 0 times 3 is 0. Combine or add all of those numbers and we get a 10. Now we're done with this row. Put a check mark here. We know we're done because we took it and we multiplied it times all of the columns over here. There's only 1 column, and so that's all we can do, okay? Alright, let's take this row now, right here, times this column over here. So let's see how it goes. Here we go. 3 times 1 is 3. Negative 1 times 2 is negative 2. And 2 times negative 3 is negative 6. Let's add or combine these 3 numbers. That's negative 8. 3 is negative 5. Okay, now I'm done with this row because I multiplied it times all the columns over here. There's just 1 column, so it doesn't take very long. Now we have row times column. 1 times 1 is 1. 4 times 2 is 8. 6 times negative 3 is negative 18. So here we go. A negative 18 and a positive 9 would be a negative 9. Alright. And that's it. This row's done because we took this row here times this column here. There's no other columns, so we know that we're finished. Now, students, one thing I forgot to do, and I apologize, is I wanted you to try each of these in your calculator too. So let's go back to the last example very quickly with your calculator. I would like you to enter, and we should know how to do this by now, okay? I want you to enter this matrix here. From the last problem we did, or 2 problems ago, I want you to enter this into your matrix. Now, I'm not sure if you're going to enter it under A or B or C or D, whatever, but go ahead and enter this into your calculator, sorry. Go ahead and enter this matrix into your calculator, and I'm going to pretend you're putting it under A in your calculator. Then when you're all done, enter this matrix into your calculator under whatever you want. I'm going to pretend it's B, okay? Then hit second quit. Second quit. And then go back into your calculator and hit enter on matrix A. And when you do, here's your calculator. Here's your screen right here. On the screen, if you go to second matrix and hit enter on matrix A, this will pop up on the screen. Then hit times, and this little asterisk thing will pop up. Then go second matrix, hit B, and this will pop up. And then hit enter. And when you do, the answer in matrix form will pop up. The answer that we got when we work this out will pop up, okay? I would also like you to take a second. In fact, I'm going to move on. So if you guys probably aren't done yet, go ahead and pause the video and try that. And I want you to try it again on this one over here, okay? So go ahead and try this one. I'm going to move on. So my advice to you is to pause the video. Maybe you'll type this in your calculator under matrix C and matrix D. So with your screen, you would take C times D, okay? Go ahead and pause the video, work on that, and when you're done, then go ahead and restart it, alright? Okay, moving on. Okay, let's go ahead and multiply these matrices together. And here we go. Now, maybe we can, maybe we can't. Let's see. This is a 3 by 1. This is a 1 by 3. This is so weird, guys. Look, your inside numbers match. And from this little matrix here and this little matrix here, when you multiply them together, look what you're going to get out. You're going to get out a 3 by 3. That's crazy. Okay? So we're going to get out a big 3 by 3 from these two matrices being added together. So I've got my 3 rows and my 3 columns. And so here we go. Let's go ahead and do what we know what to do. We know it's rows times columns. So here we go. Here's my row right here. Here's my row times my column. Got it? So 2 times 1 would be 2. Now take your row times your column. That's going to be -4. And then row times column is going to be -6. So I'm done with this row here. Check it off. Now I'm going down to this row here times this column here. 1 times 1 is 1. And then this row here times this column here. 1 times -2 would be -2. And then we take this row times this column. 1 times -3 would be a -3. There we go. Now we're done with this row. Now we take this row here and multiply it through times its column. 1 times 1 is 1. 1 times -2 is -2. And 1 times -3 is -3. Okay. So there we go. We multiplied 2 matrices together. Now if you want to, I will leave this up to you guys. You're more than welcome to quickly type this in your calculator. You could use maybe matrices E and F on your calculator. Type them into your calculator and then go down to second matrix, hit enter on E, and this will pop up on your screen. Then hit times, then hit enter on matrix F, and this will pop up. And then hit enter, and you should get this matrix here, unless we made a little mistake over here somewhere. Okay? Alright, so not too bad. We're making some pretty good time here. We've looked at adding and subtracting matrices, multiplying matrices, and also what equal matrices are. So we're doing pretty good on time. Alright, let's continue on to this next part. Let's take a look at one more matrix topic. There is a special matrix, students, called an identity matrix, okay? An identity matrix. Now, here are some things that you need to know about identity matrices. Please write these down, okay? Alright, here we go. Number 1. They are always square matrices. If you're going to have an identity matrix, it will always be a square matrix. Okay? Alright, moving on. Number 2. They will have 1s starting at the top left corner, continuing diagonally to the bottom right corner. Now I'm going to put one more up here. I'm going to stop for a second and let you guys get caught up. Number 3. All other entries that are not 1s or 0s. So go ahead and copy all this down. There's one more. Number 4 I'm going to put up in a second, but I want to give you an example or a picture of an identity matrix. This is an identity matrix. First of all, it's a square matrix. Secondly, I have a 1 at the top left corner, and going down diagonally, the 1's continue until I get down here, and all other entries are 0. This would be an identity matrix, a 2 by 2. My 1's start here in the top left corner, work their way down to the bottom right corner. Everything else is zeros, okay? This would be an identity matrix, a big old 5 by 5, okay? That would be an identity matrix. I know you probably don't want to write all that down, that's fine. But first of all, it's a square matrix. 5 by 5. Secondly, in the top left corner there's a 1, and it continues diagonally with all 1's all the way down to the bottom right corner, and all of their entries are zeros. Okay? All of these three things are true always about identity matrices. And one more thing I'd like you to write down. Whenever a matrix is multiplied by an identity matrix, you will always get out the matrix that you started with. Okay? I'm going to prove that to you in a second. Well, I'm not going to prove it to you. I'm going to give you some examples. Okay? Oh, one other thing I forgot to mention to you guys, and I apologize. I'll come back to this page in a second. I want you to know something right now. Police students, listen to me, okay? Look, understand that just because, you know in regular mathematics, 2 times 3 is what? 6. And 3 times 2 is what? 6. Whenever you swap two numbers in regular multiplication, you get out the same answer. That is not necessarily true with matrices. Okay? It is not necessarily true. Sometimes it is, but usually it's not. So if I took C times D, these two matrices here, that would not necessarily be equivalent to D times C. Please don't forget that. Okay, move back to where we were. Okay, now, let me go ahead and give you a couple examples of this. Whenever a matrix is multiplied by an identity matrix, you will always get out the matrix that you started with, okay? So with that in mind, here we go. Watch carefully how this works. Let's make up an identity matrix, okay? Let's just make one up that's easy, like a 2 by 2. 1, 0, 0, 1, 1, 0, 0. And we're going to multiply that by another 2 by 2 very quickly, okay? Now, if you don't want to take notes on this, that's fine. You don't have to. We'll just say 1, 2, 3, 4. Now, my inside numbers match, so my outside numbers will tell me my answer is going to be a 2 by 2. If you just want to watch this, that's fine. Now, row times column. 1 times 1 is 1. 0 times 3 is 0. You get a 1 here. Then row times this column. 1 times 2 is 2. 0 times 4 is 0. You get a 2. This row's done. Now take this row here times this column. 0 times 1, 1 times 3. You get a 0 and a 3. Add them together and you get 3. 0 times 2 is 0. 1 times 4 is 4. 0 plus 4 is 4. So I got out the exact same matrix. Now some of you are saying, okay, no big deal, that was a square matrix. Okay, no problem. Let's take this matrix here by a 2 by 4. A 2 by 4, alright? So 1, 2, 3, 4, 5, 6, 7, 8. Okay, I'm going to multiply a 2 by 2 by a 2 by 4. Okay, so here we go. Do my inside numbers match? Yes, they do. So I know my answer is going to be a 2 by 4. Alright, so let's get a little space here. And I have 2 rows with 4 columns. And I'm going to go really fast because this works. Row times column. You get 1 and a 0. Add them together and you get a 1. Take row times this column here. Times this column here. here, you would get a 2 and a 0. Add them together and you get a 2. Take this row times this column and you would get a 3 and a 0. Add them together and that's a 3. Then take this row times this column. You would get 1 times 4 and 0 times 8. 4 plus 0 would be 4. And this would continue if you took this row here times this column, you would get 5, 6, 7, 8, okay? It always works as long as you can multiply the two matrices together. Obviously, you can't take a 2 by 2 times a 3 by 4. It's not going to work, okay? Students, I hope this video has been a help to you. We've covered a lot of material. I don't think it's difficult material, but it's been a lot. If you have any questions, don't hesitate to call or email.